Hello and welcome back to Kiersti's virtual classroom. Today we're going to be talking about the solar system and its formation. So first things first, what is astronomy? So astronomy is not astrology. Astrology is the study of um, I'm a Gemini, I'm a Cancer, all of those different birthdays. Astronomy is the study of the universe beyond Earth's atmosphere. So anything that is past Earth's atmosphere, which includes the stars, galaxies, solar system, planets, etc., is considered the study of astronomy. The universe comprises everything. So that would be all matter, energy, and space. And as far as galaxies are concerned, there are over 50 billion across the entire universe. And we happen to live in the Milky Way galaxy. And then our solar system composes 8 planets that orbit the sun, but there are many other solar systems within our own galaxy. And our sun supplies all energy to the life on Earth. Without the sun, we would not have life on Earth. So how did this all start? So the Big Bang Theory explains the beginning or the development of our universe. At its simplest, it says that the universe as we know it started with a small singularity and then expanded and inflated over time. So this is the creation of basically everything from nothing, which is really hard to grasp. So I'm not expecting you to be able to fully wrap your brain around that. But just know that around 3.8 billion years ago, the Big Bang occurred and started the expansion of the universe. And so now everything continues to expand in the same fashion that, let's say, raisin bread would expand in your oven. So that's what that example is over here. So over time, the universe is getting further and further apart. And we can measure that by how far Earth is getting apart from everything else in our own solar system. So early scientists believe in something called the geocentric model, which says that Earth is the center of not only our solar system, but also the universe, thinking that Earth was basically the most important planetary body in all of the universe. This has since been disproven. Obviously, we know that today all of the planets in our solar system orbit the sun, and the sun is much larger than all of the other planets. This model doesn't necessarily indicate that. Okay, so like I said, we live in the Milky Way galaxy. That's where our solar system lies. And it is a barred spiral galaxy. So instead of just being a regular spiral, it looks like it has a bar in the middle of it. So that gives it the barred spiral effect. So our Milky Way galaxy is about 100,000 to 120,000 light years in diameter, and it contains approximately 200 to 600 billion stars. There is approximately 50 billion planets within our galaxy, and we think that about 500 million of them might be located in their habitable zone of their parent star. So Earth is the only planet in our solar system that is within that habitable zone. And we think that there are about 500 million more in our galaxy alone that might be within their habitable zone within their solar system, which is kind of cool because that means that there might be other life out there, but it's so far away, it's really hard for us to try to prove that. Okay, so where is our solar system located within relationship to our Milky Way galaxy? So this is the center of the Milky Way, and this is where our sun lies. So we are still not even the center. Our solar system isn't the center of the Milky Way, so we're far from the center of the universe. Okay, so our solar system is approximately 4.5 to 4.6 billion years old. That's when planetary bodies started actually orbiting the sun and started developing their round shape. So our solar system is a collection of objects that rotate around the sun or orbit the sun, most of them orbiting in an elliptical pattern. And our solar system comprises planets, moons, asteroids, comets, and dwarf planets. Dwarf planets is a newer term, relatively, because Pluto used to be a full-blown planet, and now we consider it a dwarf planet as of 2006, and I'll talk a little more about that later. And the mass of the sun makes up about 99.86% of the solar system mass. So almost all of the mass of the solar system is located in the sun. Here's a map of our solar system. You've probably seen this in grade school. But here we have the sun, and then we have the 4 inner planets here. So the 4 inner planets are Mercury, Venus, Earth, and Mars. These are all made of rocky material, so they end up in a very close proximity to the sun because of the orbit, and all of the mass is mostly concentrated in the sun. So you see all of the rocky, very dense planets very close to the sun, and then your gas giants, or your outer planets, also known as Jovian planets, are located in the outer reaches of our solar system. So that's Jupiter, Saturn, Uranus, and Neptune. So while Jupiter is the largest of the 8 planets, it is by far not the densest. The densest would be Mercury. Okay, so you have your inner planets, and then they are separated by the asteroid belt, which is where all the asteroids orbit the sun. And then we have the outer planets. And then just beyond the reaches of Neptune, we have Pluto, our dwarf planet. So again, our inner planets, or our terrestrial planets, sometimes referred to as rocky planets, are Mercury, Venus, Earth, and Mars. So Mercury is the smallest and closest to the sun. It has the shortest orbital period of 88 Earth days. Mercury was named by early Greeks after the swift messenger of the gods, and the temperature range on the surface is quite significant. It ranges from 473 degrees Celsius on the side that faces the sun to negative 173 degrees Celsius on the dark side that points away from the sun. So a very drastic temperature difference. Because it's so small and close to the sun, it doesn't have an atmosphere, and it rotates about 3 times during every 2 rotations around the sun. Moving on to Venus, it is the closest planet to Earth proximity-wise, so distance. We're not talking about physical properties here. Venus is the 3rd brightest object in the sky. It was named after the goddess of beauty. And the surface cannot be seen because it's covered in these very dense, thick clouds. But we do have some radar images from the Magellan that show us that the surface of Venus might be composed of black, hot rock, which would be probably volcanic, coming from a volcano. And we'll learn more about volcanic igneous rocks when we get to that module. And then Earth, you'll learn about all semester, but we'll do a little bit. So it's the 3rd planet from the sun. It is the largest of the terrestrial planets, making it the 5th largest in our solar system. It's the only planet with life. It takes 365 days to orbit the sun, and we have 1 moon. Mars is the next planet, and it has that distinct red color that you can see from Earth. It was named after a Roman god of war. And the surface of Mars has some really cool features, and we'll talk about those independently. But it has extinct volcanoes, and then it also has ice caps. It's the only other planet in our solar system that contains ice caps. But they're different. They are frozen CO2 in the winter, and then CO2 vapor with frozen water in the summer. So it's kind of complex, and there are a lot more voyages planned to try to investigate more. But they are the only other planet with ice caps other than Earth. So Mars is most explored for life because it has a lot of similarities to Earth, and it's close to the habitable zone of our solar system. So Curiosity is the most recent exploration that launched in August of 2012. In September of 2013, the rover actually discovered an abundant source of water in the soil. So the way that they did that is they collected samples, a sample of dirt, weighed that sample, put that sample then in an oven to basically dry out, and then we re-weighed the sample, and it lost 2% of its mass, which they are equating to potential water. Because if you do that with soil from outside that has a little bit of saturated water in it, you weigh it first, you dry it out in your oven, and then you weigh it again, it's going to weigh less because you evaporated all the water. And what's really cool is the fact that we had a rover that was able to do that by itself on the planet. That's pretty remarkable. So we've been able to do a lot of really cool things with rovers these days. Other cool features that it has the largest known volcano in our solar system, so that would be Olympus Mons. It also has a very deep valley or canyon called Valles Marineris, which is similar to our Grand Canyon, but it's much, much larger. Okay, so here's Mount Olympus or Olympus Mons. It's the largest known volcano in the solar system, like I said. It's about 24 kilometers in height, so that makes it 3 times the size of Mauna Loa. And Mauna Loa are about 9 kilometers above the ocean floor base. So it's very, very large. Valles Marineris is also the canyon that I talked about. So this is about 4,000 kilometers in length and 6 kilometers deep. It's significant. The fact that you can see it from space, it says something. So a lot of geologists think that this is from crustal fracture caused by internal forces, so flexing of the surface basically. Our Grand Canyon is more from erosion and stream incision, but since there's no known water flow on Mars, it must be some other factor, which would be like crustal fracturing from the expansion or contraction of the surface. All right, moving on to the outer planets. So these are our Jovian planets or our gas giants. They are Jupiter, Saturn, Uranus, and Neptune. So Jupiter is the largest planet in our solar system in both volume and total mass. The density, though, is only about 1 gram per cubic centimeter, whereas Earth is closer to almost 3 grams per cubic centimeter. So Earth is about twice as dense as Jupiter is. It's named after the Roman goddess of heaven because of its brightness and giant size. It's about 11 times Earth's diameter and 318 times more mass. Jupiter is covered with a thin layer of clouds that are composed of hydrogen, helium, methane, ammonia, and several other things. And it does have 4 moons, which are Callisto, Europa, Io, and Ganymede. It has more moons than just those 4, but those are the 4 that are specifically named, and they are the largest. Okay, it has a giant eye or red spot that most people have heard of, so it's very easy to identify Jupiter with this giant red spot or great red spot, and it's said to be a hurricane-like storm that has lasted hundreds of years. And the reason that we know that it's lasted that long is because since humans have been looking up into the night sky, it's been there, and it hasn't ever disappeared. So it is a very, very long hurricane-like storm potentially, and it moves in a counterclockwise rotation. Moving on to Saturn. Saturn is probably one of the most spectacular things that you will see from Earth, and that is because it has those rings. This is an artist rendition, by the way. This is not a actual photograph. It has the rings that orbit the planet, and they orbit at a 27-degree difference from its orbital plane. So if its orbital plane is here, it's a 27-degree offset. Okay. The rings are thought to be ice and ice-coated rocks, and they range from micrometers, so very small, to up to 10 meters for each of them. The Saturn is actually 9 times Earth's diameter and 95 times more massive than Earth, but its average density is only 0.7 grams per cubic centimeter. So we're going down. Remember, Jupiter was 1.3, now we're at 0.7. So we're significantly decreasing in the density. Next would be Uranus. This was discovered in 1781, so these were discovered a lot later than these other planets, and that's because they're so far out in our solar system, they're harder to observe. It was named after the father of the Titans and the godfather of Jupiter. There is a thin ring around it that is composed of about boulder size, less than about a meter, particles and some dust-sized particles. And its density is a little bit heavier, but it is smaller than Saturn. And so one of the really interesting things about it is not only a very nice blue color, but also has faint rings like Saturn does as well. And it also rotates on its side. So here are the rings around it. So it rotates on its side instead of rotating like this with all of the other planets, it turns on its side. So the rings around Uranus are perpendicular to the orbit of the other planets. Right, and then Neptune was discovered much later in 1846 by a German astronomer, and they only discovered it because they were looking at Uranus really closely and noticed that there was something else that was disturbing the orbit of what they perceived Uranus's orbit should be without any other planetary influences. And that's how they discovered the blue Neptune. So Neptune also has a large dark spot, similar to Jupiter's, which they think to be a large wind system, similar to Jupiter's hurricane system. Neptune and Uranus are very close in size, and their composition of their atmospheres are also very similar. So oftentimes they're referred to as the blue twins. Okay, so what distinguishes whether it's a planet or some other planetary body? So there's something called the International Astronomical Union, and in 2006, they adopted a specific criteria for a solar system body to be considered a planet. And there are three categories. So the first one is it has to orbit the sun. The second one is that it has to have sufficient mass for self-gravity and form a nearly round shape. And three, it must be the dominant body within its orbit. And that last statement disqualifies Pluto as a planet because part of its orbit falls into Neptune's orbit when it's orbiting the sun. And because it falls into Neptune's orbit, Neptune becomes the dominant body within that orbit because Neptune is much larger than Pluto. So Pluto is considered a dwarf planet now. So sad. I grew up with Pluto being a planet, and there were 9 planets, and now there's only 8. Okay, so of the dwarf planets, Pluto is the largest. So here's that sentence that I just talked about. So Pluto orbits into Neptune, so Pluto is not the dominant body. So we have Pluto, Ceres, and Aries are now designated as dwarf planets. So Ceres is the first one. This one lies between the asteroid, or in the asteroid belt, excuse me, between Mars and Jupiter. It was discovered in 1801, and it has a diameter of only 940 kilometers. That's the smallest dwarf planet. It's really tiny. But it is said to have a rocky inner core, a thin outer dust, and maybe a water ice layer. Pluto is the second dwarf planet from the Sun. So it's named from the god of outer darkness. It has an average density of 1.65 grams per cubic centimeter. It was discovered in 1930, and it doesn't resemble either of the terrestrial or the Jovian planets. It's kind of its own special thing. Nothing has been visited by space except for in 2015. So there was a flyby in 2015 where they took a bunch of pictures and got some really good resolution images of the planet. And that one actually is now going to escape into the Kuiper Belt, which is the extended reaches of our solar system. So here is a little bit of the orbit of Pluto. So it orbits at a much greater incline than the other planets. The other planets are very similar to each other. And Pluto, because it orbits at this great angle, it ends up crossing into Neptune's orbit twice during its orbital period. So Aries is the third dwarf planet from the Sun, and it's far, far beyond Neptune and Pluto. It wasn't discovered until late, and it was known as 2003 UB313 or Xena for a while until it officially got the name Aries to kind of match the other planetary bodies, being a Greek name. So it's the goddess of chaos and strife. It's slightly larger and about 3 times farther away from the Sun than Pluto is, and it has a highly elliptical orbit that takes 560 Earth years for one revolution around the Sun. So it's pretty far out there. All right, moving on to moons. So our moon was landed on in 1969, and the first word transmitted was Houston. So the real cool thing about our landing on the moon was that we were able to put reflectors or like mirrors on the moon that we can shoot a laser beam to and then measure basically the distance between Earth and the moon and see if it's increasing or decreasing or what's going on with that, which is really cool. It helps us with some of the rates of continental drift, our distance to the moon, the change in the Earth's tilt, all kinds of things. So our average distance from the Earth's surface to the moon's surface is 384,000 kilometers or 240,000 miles. We're still pretty far from our own moon, which is the closest thing to us. Okay, it's the second brightest object in the sky. The origin of moon is unknown, but it doesn't have any fancy name like some of the other moons in the solar system. It's just called moon or Earth moon. A lot of people have very religious ceremonies and cycles regarding the moon. Our month is based on the moon cycle, and the human ovarian cycle is also synchronized with the 29.5-day lunar cycle, which is kind of cool. So the moon is pretty important to our life on Earth. So the origin of the moon, this is the most widely accepted theory, which is the Great Impact Theory. So a planet-sized object about the size of Mars struck Earth around 4.4 billion years ago, which resulted in a bunch of material kind of being shot out. And then eventually that was pulled in by the gravity of the Earth and started orbiting the Earth. And then gravity of the material formed the ball that we know as the moon today. So this is the Great Impact Theory, which is the widely accepted theory for the origin of our moon. Okay, so our moon goes through a lunar phase throughout the month, and we have a couple different vocabulary terms here that may not be familiar to you. So we have the waxing phase, the waning phase, a crescent moon, and a gibbous moon. So knowing these definitions will kind of help you figure out what phase we're in. So the waxing phase is when the illuminated portion is getting larger. So remember, we only see half of the moon. The other half is facing away. And so the waxing phase is when we're starting to see more and more of the moon, more and more of the half that we can see. The waning phase is when we're starting to see less and less of the moon. And the crescent moon is when we can see less than half, and the gibbous is when we can see more than half of the visible portion. So let me explain. So the new moon starts between the Earth and the sun. So this is when you can't really see the moon. Then we get into the waxing crescent. So we're starting to see more of the moon, but we don't see more than half. We only see the crescent. Then we get into the first quarter, which is when we can see a quarter of the moon because you see half of the moon, which is half of the overall moon, right? So you can see half of the visible portion. Then we get into the waxing gibbous. So we're seeing more moon, but we're seeing more than half of the half illuminated side. And then you get into the full moon, which is when you can see all of the moon. It's beautiful. Then we start getting into the waning phases where you're losing light. So you get into the waning gibbous where you can see less than half of the illuminated portion. Then you get into the last quarter where you can only see half of the illuminated portion, the portion facing Earth. And then you get into the waning crescent before you move into another new moon. So those are the phases of our moon. Sometimes it gets into a little bit different things like eclipses. So eclipses are really cool. This occurs when the moon blocks some or all of the sun's rays from an observer on Earth. So a solar eclipse would occur when it is at or near the new phase. So when it's becoming a new moon, or it's near the ecliptic plane. So when the moon lies between the sun and the Earth in a nearly straight line, the moon's shadow will fall onto the Earth, and so you can't actually see the sun. So solar eclipses would look something like this. They may have a solar corona during a total solar eclipse, or in a partial, you would see an umbra, which is this. And we had one of those a couple years ago that you could see here pretty clearly, and they're really awesome. But make sure that you're wearing protective eyewear before you actually look up at it. It's dangerous. Okay, and I will see you guys in the next video. Bye.